For my Choose Your Own Lab report, I elected to do one of those provided. I ended up deciding to do the solar system one, as I thought it was the most interesting. The problem presented is simple. Model the solar system in VPython. The chief result of my lab was that the model worked, allowing me to calculate the length of day, month, and year on Earth, which was done in seconds. In order to effectively complete this assignment, a data table, as seen here, consisting of various measurements and values was provided to us. I found the distance from the Sun, the period of revolution, the orbital speed, the diameter, and the mass all to be of particular use for this assignment. In order to model the solar system in VPython, I first created the planets, as you can see here. I used the diameter provided in the table as to find the radiuses. I then made a trail for each planet so that their orbits could be more easily viewed, as their size was insignificant when compared with that of the Sun. I then initialized the masses of each planet using the provided table. Their positions were also initialized based on data from the table. The initial momentum of each planet was then calculated by multiplying the mass of the planet times its velocity. The universal gravitational constant was also initialized along with the Sun. In the loop section of the code, I set it to be less than 165 seconds, which in the model was equivalent to 165 years. This is due to the fact that the time of one complete orbit of the last planet in my solar system, Neptune, was 165 years. Within the loop, I calculated various forces acting upon each planet, including the gravitational force, which was computed by multiplying the gravitational constant times the mass of the planet times the mass of the Sun divided by the magnitude of the relative position vector squared. When I run this model, you can see that it produces 8 different orbits of the 8 planets in my solar system. The green orbit is Earth. This large space between the orbit of Mars and Jupiter would be where the asteroid belt would be in the real solar system. It takes some time for it to complete, as it has to run for 165 seconds in order to plot the entire orbit of Neptune. And here it is, finishing up, finally coming around. When it finally finishes, which it will very soon, you will see it produces the number of revolutions, which was almost 165, the length of the year in seconds, the length of the month in seconds, and the length of the day in seconds. Thus, I successfully completed this section of the lab. Thank you all for watching, and I hope you have a great summer.